Welcome to Chapter 9, Examining the Point Data Objects. In this particular video series, we're going to be focused on the various objects and their tables that we deal with for the point data. We're not going to be talking about how to populate the data. We're going to just be going over the various objects, tables, and columns. So if you're looking for anything on populating, it'll be in a later video. There are four objects that we use for point data: the site table and object and table, the peton object and table, the transect, and the site association. Site is that spatial area that you're standing on that you can identify an X and Y coordinate. The peton is that hole that you dug in the ground and identifying the layers and the soil properties. The transect, of course, is that method of identifying composition of a map unit. Typically what we'll do is transect across a map unit polygon, starting with a defined distance between line to line. And then the site association is used after all of the data is entered into the database, and what you're trying to do here is identify a association of sites, and they could be for anything, for a dynamic soil property investigation, soil health investigation. It could be for a sampling, just for characterization, and what you're trying to do is manage a group of sites, and we'll discuss more of that when we get to it. So we've got site, peton, transect, and site association. We have no data in our selected set. We have no data here in our local database. So therefore the first thing you need to do then is query the database to retrieve data. There are a lot of different queries, and if I have time I'll go into more detail on each one of these. But suffice it to say, I'm going to use the one that says peton and site by author name and user peton ID. And I'm going to run this against the national database, and I'm going to choose, notice if I choose site, I'll get the sites. I'm going to choose peton, and the reason why I choose peton is because peton is linked to a site and peton is linked to a transect. And so when I choose peton as my target table, I get the site and the transects along with it. User peton ID I'll discuss here in a little bit when we have some data loaded, but for right now I'm going to use an asterisk, and I'm going to choose all of the petons that I am a member of in the describers column. So I'm going to run this particular query. And here are all the petons. There are 154 petons that I have my name in the describer's name. I'm going to go ahead and accept this because we're going to use this set of data to look at and analyze these point data objects. And now you'll notice that all of this is now in my local database. So we can now query the local database and load up some information into our selected set. So once again, we're going to use the same query. And I'm going to choose site and peton this time. Remember, local queries run differently than national queries. So I'm going to choose the target tables I want. And I'm going to, once again, pardon me, use the asterisk and then my name. And the reason why I got my name with asterisks is because there are numerous ways of running, pardon me, not running, but populating a describer, and we'll go into that in more detail. But what I want to show you here is I've loaded up 152 sites and 154 petons. Why are they not one-to-one? Okay, the reason why they're not one-to-one is because a site can have multiple petons on it. In one case, I can tell you for a specific example, I went to a particular site for a TUD, a taxonomic unit description in a county, that was originally described in 1957. I went back to that particular TUD location and redescribed it later on somewhere in the 2000s. And so I used that same site, but I have two petons, the original 1957 peton that was described, and then the 2000 peton that I described. So that's one method of being able to understand why there are multiple pedons to one site. The other instance is where the two pedons were located so closely that the X and Y coordinate didn't change. And in that case, what I did was I used the same site and I dug a pit for a particular pedon description and described it. And then I went off site, but still within the XY coordinate, and dug another hole as a satellite description. And so that is the same site with two different pedons. So that's a case of why it was done that way and why it's not a one-to-one relationship. So I'm going to say yes, and we're going to go ahead and load this up. Okay, I'm going to clean up some of this. I'm going to go ahead and close out my Explorer panel and dismiss it. And I'm going to dismiss my status message panel. And I want to discuss some consistency in the database. A database lives or dies based on the consistency in which the data is populated. I want you to remember that mantra, because the reason why we have national mandates on the way we populate data is for consistency's sake. User site ID is a required field for the site table, and it also has specific methods in which the data is populated in this field. Historically, and I'm talking well over 50 years of soil survey activities, we have used a code system to be able to populate the site IDs and the pedon IDs for pedons. And the reason why is for consistency in a national program. This is not your local database. This is not your regional database. This is a national database. And the consistency is required in order to allow us to query and analyze data. The system is, it starts with a calendar year. You'll notice all of these have an 01. This was sampled or described in 2001. It's followed by the state two-digit code, KS or CO. You know these were done in Colorado. You know these were done in Kansas. Following that is the county code, the county FIPS code, and that is 087-075-093. You know which county these were sampled in that particular state. And then we follow that by a three-digit sequential number for that calendar year. This consistency allows us to query across the nation and identify pedons that were sampled in a tabular database to be able to analyze data. Now, as I scroll down through this list, the first thing you'll notice is that we have a slight change. We have a 2014. The lab has put out information allowing the use of a 4-digit. Matter of fact, they prefer to use a 4-digit now. And that's fine if that's what you choose to do. The 4 digits fine. The HA, we have no idea where it's from. The other thing is these numbers here. This should never be allowed to happen. This data now has no method of being able to query and analyze it in a national program. And this is very poor database management. Should never been allowed to happen. When you follow this up, here's a 1957 Kansas 075. It was a 35th pedon that was sampled or described in that particular county. As we scroll down through the list, you can see the consistency allows us to query the data. Here's one S1983 TX229002. This once again allows you to identify where it was sampled. These are improperly populated, should have never been allowed to populate like that. The S in front of these means that these were sampled for characterization data. These here should never have been allowed to populate this way. TX622 is the sole survey area code. It is not the county code. The county code is 043. Consistency is the key to a database. And the reason why we have mandates on these is so that everybody populates it the same way, and we can query against the national database and identify pedons based off of year, state, county FIPS, or even the sequential numbers. So that's enough on consistency in the database. This is the reason why it's consistent. In NASIS 6.3, we've added a few columns in the database. And I'm going to go into this in a little more detail into the next one. This is probably going to be a several series of part videos. I'm going to end this one here. I'll pick up and we'll start discussing the actual site table.